So, all right. This is so awesome that I love doing. I did this last time too. I'm gonna take another video, you guys, because when we started there were 10 people. I'm taking 1,000 photos right now. But when we started there were 10 or 11 or 12 people, and now there are hundreds. So applaud for yourself for using React. Yeah, awesome. So. Yeah, we got some beginners here. That's cool. How many people are like working in a relatively decent sized React application? That's awesome. So we have a good mix of things. And just as a giveaway, how many people have used React Packed? Redux Pack. Redux Pack. Oh, great. So I get to talk about something most people haven't heard of. That's cool. Anyway, I'm going to talk about the patterns that I've used over the years. I've been working with Redux and React since they came out. I guess I worked on Redux with Redux and a little bit on Redux back when it was pre-1.0. And I've kind of done the same kind of apps over and over again, a lot of CRUD apps and, you know, just what we all kind of really do with the front end. I am Dan. I work at Instrument, and guess what? We're also likely hiring. So want a job? Yeah, I got the mic. And you can find me at that stuff over there. So we do have some beginners here. So before we get into the async patterns in Redux, I want to just do a brief recap of promises. Some people might not know how they work. Maybe this isn't going to teach you that, but it might at least give you an idea of what the hell's going on. And so then you can go learn promise. This is a promise. When you create it, it gives you access to resolve or reject the promise in the future. So in this situation, we're saying in the future, sometime, in 5 seconds actually, we're going to either resolve or reject it. So half the time, it's going to say hooray. The other half of the time, it's going to say uh-oh. And once we execute that function eagerly starts going. So it's actually, even right as it's defining that my promise variable, it goes ahead and executes that inner function. So your timeout's already starting to tick, as much as JavaScript allows that to happen. And we can consume it in a function. So we define this function consume promise, and we work with it like this. We're able to attach then or catch callbacks onto it, so that in the future, when we call this lower function here, this consume promise with that promise that we defined, it will immediately return that done string right there. But in the future, it will console log out one of those outputs. So that's like a super crash course on promises. Probably gonna want to learn more if you don't know that much, but it's great stuff. And then this is the async await sugar. So if we append or prepend async for the function, it turns all that code into much more synchronous looking stuff. So it reads a little bit better. When you see this await token right here, it's going to do what you would expect. It's going to wait. And it's going to wait for that promise to succeed. If it doesn't succeed, it throws. And then the output could be caught. Otherwise, it will bubble out and reject the function as a whole. It does have the effect of changing the return value of the actual function call to that of a promise instead. So it wraps your value, that done value, with a promise itself that either you're able to call then on or it will reject. So catch the error, et cetera. It's going to do what you expect. You just have to tack on then to it. And another thing is that with these async functions, it's safe to attach the async keyword to a function if you don't care about the return value. And so this is the case in a lot of event handlers. So like on click, you never really return anything from there. You can just easily switch that function to async and get all the niceties of writing code that looks a lot more linear, even though it's not. And the same goes for some lifecycle methods of React. So such as component did mount, component did update. Those don't have any return values that matter. Not so much with the newer ones that return the next state, but that's async await and promises in like, what, a minute or two? So hopefully that clues people in if they're not up to speed with all that. So we have a little bit of time, so I'm going to ask somebody randomly, maybe it'll sync up with what I have on the next slide. Why do we like React Redux? So, I mean, do you guys like React Redux? I don't know. Does anyone want to raise their hand and shout out an answer? Okay, so he said when you want to distribute state and when you want to synchronize state across your application. That's a good use case for it, but even more generally, what I think is what I like about React and Redux is that is what's said by Sebastian, is that the core premise for React is that UIs are simply a projection of data into a different form of data. So we're able to think about our data as this one-way function. You know, data goes in, UI comes out. It doesn't go the other way around like it did with Angular and a lot of other two-way binding systems. That's why React caught on like wildfire. It helps us easily think about our applications. To that end, this is the conceptual model of Redux as well. You have a previous state and an action, next state comes out. It's that one-way flow that allows us to reason about our application a lot better. It's a kind of functional-like mindset. So everything about React and Redux isn't necessarily functional, but it kind of helps us work in that way where where it's just so much simpler to think about. Who's here's worked with Angular before? Who here still wants to work with Angular tomorrow? Oh, where'd the hands go? Yeah. So obviously it has some merit to it. We all love it. That's why we're here. So I'm going to go ahead and assume that everyone knows how props work in React and delve into the asynchronous aspect of React. This whole setup of React being a projection of some data into some other data, great. But when events and asynchronicity come into play, things become more complicated. So this is my version of the simplest React component that is asynchronous that I can think. It doesn't involve promises or anything like that. It's just a button, and it has an event handler that when it is emitted from the DOM, when it's called, we trigger a timeout. And then sometime in the future, we have access to the closure that calls set state and increments some buttons state. Kind of the canonical counter example in React. So nothing fancy in there, but it still holds to that same tenet of where when you provide new data into React, a new UI comes out. And similar to this, the simple DOM method, the DOM event handler, we have lifecycle methods. So they also are emitted sometimes at random, you know, when the component mounts or when something new comes into the component. And some of them are suggested as opportunities for our React components to do network requests or other asynchronous things. So in this case, when this component mounts, this is an opportunity for us to leverage that async await stuff where we just tack on async into the component did mount, and we're able to get a response back. When it eventually comes back in the form that we want, we're able to trigger off a set state call again. Great. Wonderful. Similar to that one is component did update. So those two lifecycle methods, component did mount and component did update, are the places usually where you will reach for normal components to do asynchronous work. The difference in component did update is that we have this area where we need to check that something changed in the way that we wanted it to. So if we don't, that can get called again, and it's not a fun Stack Overflow sort of. They did truncate that URL, you know, but yeah. This is a useful way of working with stuff where your parent component data changes and you don't want to be passing around callbacks. So you do this kind of detection of, did this prop change? Then that's a good way of a parent component indicating to you that you need to do something. The other option would be passing callbacks around. Sometimes it's not possible or appropriate. So these lifecycle methods in just pure React, no Redux, are the core asynchronous mechanisms that we can use in React. Both events that come from the DOM and these lifecycle methods are the general places where you will work with asynchronous work. And that's all great, but then we have Redux. And so everybody here is using Redux, I guess. Can we just see the hands again who's using Redux? Yeah, it's great, maybe, sometimes. I love it, but it can go, it's so simple at its core, it can go a lot of different directions. So I want to talk about, before getting into asynchronous work, mainly two of the main things that I find can go wrong in Redux applications in general, that people think might be wrong, but are actually right. The first one is local state. So what we talked about before, those components having state. Local state is fine. The God King himself says it. It's a trade-off. Just to read what's up on the screen, it adds indirection to decouple what happened from how things change. Is it always a good thing to do? No, it's a trade-off. Jamming everything into Redux is the worst thing you can do to your application. It turns into so many nasty little patterns that are hard to understand, when all you may want to do is have a counter button. You can have that state local without having to go into these layers of indirection with Redux, middleware, and any sort of, is it a thunk, is it not a thunk, etc. So yeah, I love Redux myself when it's being applied correctly, but in situations where you can really keep that logic as closed off, compartmentalized as possible, I suggest doing that. So that's just something to keep in mind. And then unrelated to this is action handlers. So action handlers are not one-to-one. Actions and handlers, rather. So when you have something that, and this goes to like the pattern of, say, you have a, I don't know, a list of dogs, maybe, like I have going on here. You might see actions that say set dog breed, and then set selected dog breed, and then set, all these setters, getters, and not getters, but just setters. That sort of pattern is not what Redux intention was. Sometimes they are one-to-one. Sometimes you'll have an action and it only has in one of your sub-reducers a single consumer. That's fine, but sometimes they aren't. And sometimes they are now, but later they're not going to be. And when you don't prepare for that sort of pattern, your code can grow in all sorts of unwieldy ways. So I just want to show off like a basic action handler. This is an action creator. It takes in a dog ID, and then you like the dog. You give it a thumbs up. One of the most simple action creators we can have. So what I'm talking about is this type of pattern, where you have multiple reducers all over the place. You can separate your logic. You can compartmentalize your things, your reducers, and in one part say, if this action is like dog, do this part to this substate, and then in the second part, increment something else or perform some other logic on it. It allows you to divide up the intention of your app and make things a lot more easy to understand. You're still able to debug as easily because the reducer is synchronous. You can still say like, oh, from this action, this state changed in a way that wasn't what I intended. Let's go, debug into that and find out why. It just helps you work with data in a more segmented way. This pattern has been also advocated by Abramov, and I've been using it a lot more heavily in more recent apps, and it works so much better than trying to keep everything one-to-one. And so a lot of time you'll see people saying like, oh, I made a simpler version of Redux that uses less boilerplate. Like, okay, first thing I do when I see something like that is that I look for this type of pattern. Usually what they do to reduce the boilerplate is to tether the actions to the action handler, and that defeats almost the entire purpose. So back to why we like Redux is the simplicity. The simplicity rules out asynchronicity. So that simplicity is enforced. This piece, you can't read that probably, but this piece of code right here prevents reducers from calling dispatch. While a reducer is in flight, you can't go and try and fire off more stuff asynchronously or anything like that. It enforces that simplicity. With that simplicity, gives us awesome tools. So how many people have used this tool? If you haven't used this tool, it's the Redux dev tools. It's the best thing that happened to my life. I mean, you got to think about it. If you work on this stuff like all day, every day, this thing has saved me so much time. So we get those awesome tools, but we are left on our own to kind of figure out how we deal with asynchronicity. So back to the on-click example, we have the same set timeout, but this time, instead of setting state, we call into dispatch. So it's the same thing. We're just calling set state essentially in a different area. This doesn't grow well. It kind of doesn't lend itself to being organized. The intention of this click action isn't necessarily to, set a timeout and then do a thing. It's just meant to kind of execute the click handler. And Redux allows us to encapsulate this kind of logic into the central dispatch mechanism itself. What we use for that is thunks. I'm guessing everybody here has used a thunk if you've used Redux. Once again, hands. Thunk, use it. Curious to how you're all using it, but we'll get into that in a second. This is the code for thunk. It's slimmed down a little bit, but that's the code. If your action's a function, call the action. Give it access to dispatch and get state. Otherwise, move on ahead. That next action usually means dispatch to the reducer with the action. That's what actually calls into your reducer at the end of the chain. So it's great. It allows us to centralize things more. Instead of putting all that logic in the click handler itself, we can just say dispatch, and then it will call our function for us. Allows us to clean up code. So now we've trimmed out that timeout logic and put it in a drawer somewhere. It's in the like dog action function. So when we call that function, we now have a closure on the dog ID. We have access to dispatch. We can do the same thing we were doing before. Allows us to move things around more easily without being as confused. The same difference, just a nicer way to work with things. So this is where, at this point, where we have this thunk, this is where things can go all sorts of directions, all sorts of patterns. People use thunks in different ways. Maybe people decide to use Redux Saga. Maybe there's some other stuff. So let's look at a simple thunk. This kind of pattern may be familiar to some of you. Same as before, we have the closure on the dog ID. Now we have an async function. We have an async function, and we're calling that fetch on the dog API to get some stuff back. We wait for the JSON. Once again, we dispatch the actual action, the result, into the reducer to update our app. So great, right? That's exactly what thunk was made to do. But it's not so great. That's what it ends up being. You end up needing to deal with the success response, the failure response, the finish response, the start response. Sometimes you need to tack some extra data into one of these, yada, yada, yada. Very boilerplatey. Doesn't grow very well. Has anyone used patterns like this all across their app? Some. Has anyone had these and changed it to something else? Curious. Yeah? Oh. Any of your apps just not asynchronous? No? Okay. So, just like we have the thunk middleware right here, we can make another middleware. So instead of looking to see if the action itself is a function, we can look to see if the action is a promise. It has a promise key on it. So if it has a promise key and that promise is a promise, this is just kind of pseudocode, then do some crazy stuff. Otherwise, continue. This is exactly what the Redux pack middleware does. So consider this function right here, or this action creator. Instead of having a payload, we have a promise key. We call this global API and do some promisey things. We send that back to our reducer, or to dispatch. The middleware will pick this up and intercept that and say, oh, well, we have a promise key. So let's go do some stuff. What Redux Pack does is take that promise and builds action handlers. It kind of packs all those lifecycle methods I talked about into the action itself. So the action will have your data at certain times. So when it's successful, your action will have the payload on it. When it's finished or start, it won't have that information because it hasn't completed it, but you'll be able to hook into it and set maybe loading states appropriately. Is anyone having trouble reading this by chance? Good. So that allows you to both leverage the pattern I talked about before of handling actions in multiple places. So maybe in one of your reducers, you will have, you'll be working with load foo, and you want to maybe show or not show a loading indicator. But in another one, you want to actually stash the result or the error state. Allows you to, once again, divide up your logic across the app. So looking back to the action itself, we have that mechanism now with Redux Pack. It puts in all that metadata. It allows us to visualize our app better when debugging. So maybe you saw that screen cap of Redux DevTools before. Instead of seeing the success, failure in the start and the finish, you see a lot fewer actions. They're more simple to look at, easier to work with, and allows you to have cleaner looking reducers that are a little bit more functional. There's also some typing patterns I've worked with in TypeScript that can make things even better, but that's not for this talk. But with this, it doesn't give us the convenience of orchestrating multiple promises like thunk. So consider something like this. I commented it out, and it's a line right through it. That's awesome. But imagine we had two promises. Imagine we wanted to call into two different API methods. We could create a new promise, and inside that resolve reject handler, call that. But that's almost the same as like wrapping it with that set timeout before. It's not really the intention to create a new promise. You just want to kick off two API requests. So here's like the example with the thunk. Imagine in this area right here, where we're waiting for this fetch, we could actually, the thunk, trigger off multiple fetches. We don't even have to await them all in series. We could parallelize them and such, just wait for all the promises, et cetera. We have that capability. We have that, since we're just working inside a function, we can do anything that we want. So what a pattern that I've come across that has been very great is building on top of existing middlewares. This is a bunch of code. So if you have access to your laptop, the gist is right up there. I tried to make this as packed as possible, but I'll highlight over a few areas. This is an API middleware that I've used in a lot of applications. So at the time of making your middlewares, in the bootstrap of your app, you can pass in a method to create a client. And that's useful, an API client. And that's useful because consider most apps are built around a single API. They might, on the periphery, work with some other stuff, but usually you're hitting one API. And it's been really helpful in all of my apps to have this kind of API client that has access to dispatch and get state for things to deal with, with tokens. Like when a user is logged in, you can just have access to the token, hack it in there, anything like that. The specifics of your API are whatever, but that client will provide methods for you to call into various APIs. And then when you have the closure over that client, we now check to see if there's another action that has a key of API. That API key is a function. We do some juggling right here and actually call the API with access to the client, wait for its result, be a promise, and then kick it off to Redux Pack. So you're building on top of Redux Pack. Redux Pack handles dealing with the bundling of actions, but what you're doing here is injecting this API client. It can help also with testing. You can kind of inject a fake API client, work with that. So just to go over that, I guess I had animations here to show the creating of the client, the testing of the API. Should have looked at my notes. But so this is an example of using it. So that middleware is all the boilerplate. You hardly ever touch that stuff. But now you have actions that look like this, a simple action creator for maybe selecting a dog breed. We can tack on some meta information there. That's part of the Redux Pack API. So considering your start, when the action kicks off, you might want to say, we're loading this breed. You know, you have access to the meta before the promise is resolved. But then we have the API key, which gives us, since we tagged it with async, it returns a promise. And now we can just work with it as we like. We can have multiple promises in here. We're waiting for it to return. And when it does, it gives us back in the Redux Pack area, over here, ways to handle that. So we can still work with success handlers, start and finish handlers. This is what I was talking about with having multiple areas deal with different things. You have a loading section of your reducers that show maybe a global loader when things are in flight. And then in another reducer, you could have something displaying your selection. Just wanted to go back to that. So that's an example of dispatching it. This is an example of consuming it. Yeah, so it allows you to work with it in a lot clearer way. You can also gang up actions. So like you could say maybe if actions share the same similar response shape. So going back to here, imagine if you had a lot of things that returned the breed response from your API. You could, in the reducer, have something say, oh, if it's a select breed action, or if it's an update breed action, or if it's this, the shapes are all going to be the same. Do this with the handle method, and it works appropriately. Types well too in TypeScript. Yeah, so that is kind of an overview of the patterns that I've used with Redux Pack, kind of building on top of it. There are some other options. There's Redux Sagas, which I haven't really used much. Who here uses that in production? Few people. It's really interesting, but I find it complicated. It's kind of it's a little difficult to wrap your head around. It's really cool though, because it treats asynchronicity as this loop, but a lot of developers don't want to think about things like that. So, and there's also GraphQL. I've been looking into this because a lot of the time we're doing a lot of just fetching of data and getting it back and putting it in a Redux state, updating it, you know, the same sort of CRUD stuff. Apollo with GraphQL looks really awesome. Has anyone talked about that here? If anyone wants to talk about that, I'm sure a lot of people would love to hear it. I'd love to hear it because I was looking into it. It looks like it obviates a lot of what Redux has to offer. So Redux is good for managing state local in your app. And then usually a lot of what we're doing is trying to synchronize it back and forth between the API. And that's kind of what GraphQL and Apollo solves. So you could, you know, wipe out the need for a lot of it. And then lastly, there's the upcoming React Async API. It's going to blow up the world. So that's going to be really cool. When, you know when that's coming out at all? It's going to be weird and awesome, but it's going to change everything probably. Yeah, so just recap. My patterns that I've learned over this year are avoid setter actions, and consume your actions in multiple places. So if you have a lot of methods that are set this, set that, and you have a thunk that's triggering off multiple things like that, it's a single action. Your app already had access to that state, and you're triggering too many unnecessary re-renders and making things a lot more complicated than they need to be. Check out Redux Pack. Consider leveraging middlewares for reusable patterns. Build on top of existing middlewares. So that's all I got right now. Hopefully somebody has a question. Or am I good on time? I don't know. I also have some working code if you want to see some stuff in action, but I don't know how much time we have or whatever. But Yeah.
But imagine that for whatever reason, the loading states need to be different. That would mean that your reducer would have to process both load foo1 and load foo2 differently, potentially re-implementing the success handler.
Yeah, I guess that seems like a particular situation. So the question was, what if you have two actions, load foo1, load something one, load something two. They both have the same exact response type, but they need to be handled differently. Like the loading states need to be handled differently.
Yeah, or maybe the failure states or something like that.
Maybe you need to tack on some unique error information that needs to go into your reducer.
Right.
One thing that you could consider in that situation is trying to find my where is it? Is passing it in as a parameter to the actual action creator. So since it is the same action, you can pass that additional information into yeah, so like right here, you could, instead of having breed, you could have any other parameters like error case for foo1, it's really contrived, but
on success or
and
something.
And then you can tack it into the meta area or in a certain response shape or something like that. So that's the pattern that I would consider. Depends. It sounds like an interesting situation. Got to be at least one more. Maybe a softball question for me.
I'll ask one. Do you ever dispatch from, say you're using Redux Thunk? Do you ever dispatch from a componented mount and then just handle loading and errors within a particular component if you only need localized state?
That's an interesting question. So what the question that Jason's asking is that in a component, so here's the component that does the thing. So yeah, right here. So something like this, where the button, when you click it, you dispatch something. So the idea with Redux is when you dispatch something, you're going into the realm of Redux, and when that state updates, it will trickle down into your component from props. But in certain situations, you might want to get the result of this dispatch. Is that what you're asking? Yeah, you might want to get the result of this dispatch, do something with it. In a lot of cases, dispatch will return the action that you fired off. But with middleware, you have the capability of changing that response type. So part of that middleware, I think that I made. Also, I forgot to mention that middleware, that API client, that I didn't make that up. That originated from React, Redux, Universal Hot Boilerplate, originally made by Eric Ross. He had amazing patterns in there, and that's one of the patterns that I've taken and kind of mutated into my own. So I wanted to attribute it to him. I did not invent that. It came from there, but I've kind of adjusted it. Anyway, working with this boundary, you do have the ability to hook into the response type. Maybe it's a promise that comes back, and you need to synchronize it in a certain way. Maybe you're using a form library that you need to trigger in a callback or something like that. I try to avoid that myself as much as possible, but it's something there as like what I consider an escape hatch, where you hook into it only when you really need to. Ideally, if you're pushing something into Redux, you wait for Redux to flow it down to the rest of your. Any other questions? Easy questions? What is a promise?
Well, all right. So thank you very much. Thank you to Dan.
Thanks.